Have you ever think how the internet is working? Basically, internet is an interconnection of multiple network. When the multiple network that is located at different geographical location comes together, then that is called internet. In this chapter, we are going to discuss about the relation between the internet and IP address. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 50, Private and Public IP Address.
Learn CCNA with Irash Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar.
In this chapter, we are going to talk about the private IP address. We are going to talk about the public IP address. Then we will discuss about the differences between the private and public IP address. We will talk about the static and dynamic address. Then finally, we will talk about the automatic private IP addressing address. Let's see what is the internet. When the multiple network from different geographical location is connected together, then it is called internet. In the screen, you can see the logical diagram of internet. You can see multiple networks are connected together. And this network maybe it is located at India, and this network may be UK, and another network it may be in US, and this network may be located in France. So in this way, all of this network, it could be located at the multiple geographical location, multiple country, and when they connect together, it's all called the internet. We all know that an IP address is mandatory to connect a device into the network, and now we are talking about the internet. Internet is basically an interconnection of multiple network. So that means if you want to connect a device into internet, an IP address is mandatory. So in that way, all of the devices in this network should have an IP address to communicate with the internet. Now the question is, what is the total IP address available in this world? And do we have enough IP address to provide an IP address to each device in this world? Let's discuss that. When we talk about the IP address, there are two types of IP address available in this world. And what are those? The first one is IPv4 and the second one is IPv6. So what is the difference between this IPv4 and IPv6? That we will discuss later in another chapter in a detailed format. One of the facts that I want to tell you is the world is still running in IPv4. IPv4 has a limitation in the number of IP, but still the majority of internet is still running in IPv4. Some of the service providers already started using IPv6, but I can say the majority of internet is still running in IPv4. So here we are talking about the IPv4 address. So let's talk about the IP address. How many IP addresses are available in this world? There are 2 power of 32 IP addresses are available in this world. And what is this 2 power of 32? It is multiply the number 2 32 times. That is the answer you get. That means there are 4.3 billion IPv4 addresses are available in this world. You can take the calculator and multiply number 2 32 times and you will get the exact answer. So 4.3 billion IPv4 address available in this world. Then what is the total number of devices available in this world across the world? Is it lesser than 4.3 billion or more than 4.3 billion? Just imagine how many people are available in this world, and imagine how many devices are each individual is using in this world. They have computer, laptop, smartphone, tablet, and not only that, their refrigerator, washing machine, microwave oven, so many other devices are connected to the internet. That means the number of devices available in this world, it is more than the number of IP address available in this world. So how to provide a unique IP address to each device in this world? Is it possible? It is not possible at all. And one thing you need to remember, as we said, there are 4.3 billion IPv4 available in this world. But can we use that 4.3 billion IP address completely? The answer is no. Because the IP addresses are divided into multiple classes and you can use only some specific classes to provide an IP address. We have class A IP address, class B IP address, class C IP address, then we have class D IP address, class E IP address. So total number of IP addresses are classified into these 5 classes. And out of these 5 classes, only 3 classes we can use in the real networking world. That is class A, class B and class C. The class D is using for the multicasting purpose and class E is using for the experimental purpose. So we need to avoid the class D and class E from our list. Then what is remaining is class A, class B and class C. That means even there are 4.3 billion IPv4 address available, we can't use it completely. We need to avoid the class D and class C IP address. That means still the number of usable IP addresses are lesser than the 4.3 billion. Initially when the concept of internet was started, there was 4 billion IP address available and the number of networks are very less. So initially all of the networking devices that connected to internet was getting one IP address. And eventually the internet became very popular and number of network increased, number of devices in the network increased, number of requirement was increased, and the internet was gradually grown into a giant network. It came out of these 4 billion devices. In that situation, it was impossible to provide a unique IPv4 address to each devices in this network. So what was the workaround found to resolve this issue? To resolve this issue, one new concept was introduced. And what was that concept? As per that concept, the total number of IP addresses were divided into 2 groups. One is the public IP address and the second one is private IP address. So what is the difference between the public IP address and private IP address? The answer is, just look into that name and you will get the answer. It is very simple. The private IP address are the IP address that we can use in the private network, and those are not available into the public. And the public IP address are available in the internet. It is accessible to the public. For an example, look at the picture. Here you can see 4 PCs are connected to a network switch and the network switch is connected to a router and the router is connected to the internet. So as per the private and public IP addressing concept, the PC1, PC2, PC3 and PC4 are located inside the local network. It may be your home network or your office network, but it is a part of network of a local organization. It's a local network. So those devices should be getting private IP address. And the private IP address are restricted inside that network only. And when you see the router is directly connected to the internet. And that one interface of router, it should get a public IP address to reach to the internet. So here even we have 4 PC and 1 router, it is not mandatory that all the devices need to get an IP address that can be reachable from the internet. We can divide the total network into 2 groups. One is the private section and another one is public section. All the devices in private section can get a private IP address, and whatever we connect to internet, that only need to get a public IP address. So here one question may arise. The private IP address are not routable to internet. It cannot reach to the internet. But the PC1, PC2, PC3 and PC4 are assigned a private IP address. So in that situation, how these devices will get the internet? There is no possibility to get the internet, right? Because they have the private IP address and private IP address cannot reach to the public. So how these PCs are getting the internet? Here is the new concept arise that is called NAT. NAT stands for Network Address Translation. So what is the meaning of that? This means that multiple private IP address can be translated into a single public IP address. Here we can say the router has a public IP address. Okay, this is the public IP address. Just say it 10.11.1.13. So we can configure a network address translation, the NAT service in our router here, and all the private IP address can be translated into this public IP address. So that means when PC1 start a communication to internet, its private IP address will be mapped with this public IP address and it will reach out of the internet, because the public IP address can be routed to internet. So in this way, doesn't matter if you have 100 devices in your private network or 1000 devices, all of these devices can be NATed into a single public IP address. So all of those devices can be communicated with internet. Now let's see what is a private IP address. The private IP address are the address that you can use in your private network, such as home network, office network, or your private data center. Private IP address are not routable to outside world. That means the internet. Private IP address are decided and provided by the network engineer. So basically saying the private IP address are only restricted into the private network. You can use it in your home network, office network, or any other private network. And these IP addresses are not routable to outside world, the internet. All the service provider across the world restricted this IP address that routing to the internet. So it cannot be communicated with the internet. And moreover, this private IP address are decided and provided by the network engineer. As a network engineer, you can decide what is the private IP that you need to use inside your organization. You can use any range of the private IP address as per your network design. Now let's talk about the public IP address. The public IP address are the address that you can use in global network. That means in the internet. And they are mainly used in the data center, cloud-based services, remote VPN connection, cloud application, and peer-to-peer connection. Public IP address are routable to outside world to the internet. Also, the public IP address are decided and provided by the ISP. That means your internet service provider. So depends on which country you are located, there may be different internet service provider. And this service provider, that means the ISP, is the one who decide the public IP address. You cannot choose your public IP address. For example, if you get an internet connection to your home, that public IP is decided by your ISP. If you purchase a lease line, a broadband connection, its public IP is decided by your ISP. So you don't have a freedom to decide what public IP you need, but you can decide that received public IP should be assigned to you in a static way. That means there are two kinds of public IP address are available. One is a dynamic IP address and the second one is static IP address. So dynamic IP address, it's changed frequently. You will just get one public IP from the ISP, but it is not stable. It may change. But you can request to the ISP to give you one static IP address by paying the extra money. So that means one static IP will be reserved under your name and that is not going to change. And this static IP you can use to host your application or to use any other cloud-based service. It never change. Now let's talk about the private and public IP address range. First we will talk about the private IP address range. The private IP address are classified into different classes. The first one is class A. So if any IP address start with number 10, then it is a class A IP address. And its predefined subnet mask is 255.0.0.0. And the second one is class B IP address. So if any IP address start with 172.16 to 172.31, that is a class B IP address. And its predefined subnet mask is 255.255.0.0. And the third one is class C IP address. Any IP address start with 192.168, then it's a class C IP address. And its predefined subnet mask is 255.255.255.0. So this is the class C IP address. So here by looking to the IP address, you can understand that whether it's a class A, class B or class C. Now what is the range of public IP address? All IP address range other than these three classes are the part of public IP address. For example, here class A, it is start with 10.10.10.20. And when the first numerical value come 10, it's a class A IP address. What is something came with 11.10.10.20? Is this a class A private IP address? No, because here it started 11. So this is a public IP address. And what if something started with 9.10.10.20? This is also public IP address. So other than this one, this range, everything else is public IP address in class A. And when we come to the class B, it is started with 172.16.10.10. This is the class B IP address because it's matched with our range 172.16. And it should be between 170.31 also. So if anything coming like 172.38.10.10, is this a class B private IP address? No, because our range is from 16 to 31 only. So here it is coming 38. So this is not a private IP address. This is the public IP address. Same in the class C also. Our range is 192.168.10.10. So this is our range. So if anything coming other than this, then it's a public IP address. Just an example, 192.169.10.10. This is a public IP address because this is our range, 192.168 only. So simply saying, the provided three classes are part of private IP address and rest of all IP address are coming under the public IP address. So what's happening? A private network is connected to internet. As per the protocol, the private network should assign a private IP address, which is from class A, class B or class C. And when this private IP address reached the internet service provider filter the private IP address in their router interface. They put an access list there to deny the access to the internet. So that means this private IP address will not be reached to the internet. It will be blocked by the ISP router. So when the ISP router receive one packet, it will check what is the IP address it is coming from. If it is coming from a private IP address, it will block the access to the ISP. It will block the access in that interface. But if the communication is coming from a public IP address, then the ISP router allow that into internet. Now let's talk about the static and dynamic IP addressing. What is the static and dynamic IP addressing? When we provide the IP address to a device, there is two concepts, static and dynamic. First we will talk about the static IP addressing. In static IP addressing, we provide the IP address to a device manually. So in this picture you can see 4 PCs are connected to switch 1. If all these PCs need to communicate together, we need to provide an IP address to that. So how do we provide the IP address to that device? In static way of IP addressing, we manually go to each device and provide an IP address in static mode. So that means if you have 100 devices connected to in a network and if you need to provide the static IP of each one of the device, then you have to spend some time for that process. It is not a practical way of giving IP address to each device if you have more devices. Providing static IP of each these 100 devices, it is possible, but it consumes some time. It's a burden for the network engineer. So here is the second concept comes, it is dynamic IP addressing. In dynamic IP addressing, you don't want to give manually an IP address to each device in your network. Instead, you will use a DHCP server to do that job. So here you can see in this network, there is a server which is called DHCP. The DHCP stands for Dynamic Host Configuration Protocol. That means dynamically your server can assign IP address to the devices. So when you connect a new device into your network, first of all, it will search for an existence of a DHCP server in that network. It will look, is there any DHCP server available in this network? So once it's found a DHCP server in the network, then it will request for an IP address to DHCP server. Please give me an IP address. So the DHCP server accepts that request and it will check in its DHCP pool and see which IP address is free and can provide to this device. Then once it is finalized the IP address, then it will communicate with that device and provide that IP address to the device. So in this way, you can control hundreds and thousands of devices in your network. No need to do a static IP address or the manual IP address in each device. Instead of that, the DHCP server can manage that task and provide an IP address to each devices. DHCP server also provide a facility to reserve a specific IP address into a specific device. For example, if you want to provide an IP address to this PC3, which is 192.168.2.50, then you can reserve that IP address inside the DHCP pool. So once if you reserve that IP address, DHCP server will not provide that IP address to any other device in this network. It will provide that IP address to only PC3 because it is reserved for PC3. There is another concept of IP address which is automatic private IP addressing address, which is called APIPA. And what is this concept? The automatic private IP addressing is look like 192.254 range. That means if you see any IP address in this range 192.254, then it is an automatic private IP address. So what is the situation a device get an automatic private IP addressing? That situation is like if a device connected to network and there is two options to provide an IP address to that network. One is the static IP address and second one is a dynamic IP address through a DHCP server. So if you didn't provide the static IP address manually, then the device will look for a dynamic IP address, the presence of a DHCP server. It will send a broadcast message to the network to find out the DHCP server. So when this device cannot find a DHCP server in the network, or it didn't receive any response from a DHCP server, that device will assign an IP address to itself to communicate with the network. And this IP address is called automatic private IP addressing. So if you connect a device to the network, either you need to provide the static IP. If you didn't provide the static IP, the second part it will look for a DHCP server, and it cannot find a DHCP server. Still, this device is connected to the network. It needs to start a communication with the other devices. It is expecting some communication back also. So for that purpose, the device assign one automatic private IP address to itself so that he can able to communicate with the network or with the other devices. So just imagine in a network. If more than one devices were not able to find the DHCP server, then those devices assign an automatic private IP address themselves. So that means everybody failed to get a DHCP server response, they will assign IP address themselves, and that is coming under the range of 169.254. And they can communicate together because they are in the same IP range, automatic private IP addressing range. So they can communicate together. So for this concept, this automatic private IP addressing are used in the network. So in this chapter, we talk about the private IP address. We talk about the public IP address. Then we talk about the difference between the private and public IP address. Then we talk about the static and dynamic address. And finally, we talk about the automatic private IP addressing address. Thank you very much for watching and subscribe to the channel for more videos. Enhance your skills using iRush Academy.